Okay, now we're going to go over how to actually plot a position on the chart and how to measure a position on the chart. So, in other words, how to take a specific location, one distinct point on a chart, and say, I want to know this point's latitude and longitude. Or if you were given a latitude and longitude, how to put that down on the chart and actually find it. So, first we're going to try and we're going to do this with identifying a position's latitude and longitude. I'm going to zoom in here. We're at Montauk Point again. Let's take Montauk Point light. You can see the little light right here at the edge of land. That's Montauk Point light. Let's say we wanted to find this light's position. Well, going back to previous videos, you could actually just find this by going into the light list, and it will have Montauk Point light's latitude and longitude already listed for you. But if you didn't have one on you, or if you didn't want to open up the book, you could measure it off of this chart right now as well. That's the purpose of a chart. Remember, zoom out again. We have the latitude or the longitude scale up here and the latitude scale up here. So theoretically, you can project out a grid from those two scales there and apply them to every single location on the chart. If we wanted to then find this, we could just take whatever point on the longitude scale and the latitude scale line up and intersect at this point, and that would be the coordinates of Montauk Point. There's about two ways to do this. There's the lame way and the cool way, to put it simply. The lame way, and it's lame just because it's more work and arguably less accurate. You could begin, let's first start by just trying to find the point's latitude. So if I were to place my triangle on this meridian that you can see passing through the chart here, I know it's always hard to make out what all these different lines are, especially in a cluttered mess like this, but my finger right now is on a meridian that goes north-south and passes relatively close to Montauk Point. So if I were to line up my triangle to be perfectly in line with the meridian like that, with the window passing through, and move it upwards so that the black line also intersects with Montauk light right there. What that means now is that this black line is going perfectly east-west and passes through the light. So in other words, you could follow this line all the way over to the latitude scale here, and it would be at the same latitude. So if we do that, we could take this triangle, place it on top, put all my pressure on the top triangle now, slide this one over, it maintains the same angle, take this up again, slide it over again. I gotta move the camera. And you can see it's nearly at the scale now. If I move it over, slide it over a little bit again, that black line intersects the scale at exactly that point, which is 2 tick marks above the beginning of that black segment, which is immediately underneath the 41 degrees 5-minute mark. So what that means is if each of these little segments is 1 minute of latitude, we're 2 above the 1 beneath the 5. So this would be 41 degrees, 4.2 minutes north. So Montauk Point's light is exactly 41 degrees, 4.2 minutes north. And we did that by taking this, setting it to be exactly in line, going north-south with the meridian, meaning that this line is now east-west, passing through the light and sliding that accurately, not like I just did, over to the scale. Like I just said, that's actually the worst way to do it, in my opinion, because it's A, labor intensive, and B, you could easily mess it up when you're sliding the these together. Like I said, they could slip ever so slightly, and it'll mean that everything you just did was wrong. So what I recommend is, instead of doing that, come back to Montauk Point. Instead of worrying about this meridian here, let's talk about this parallel right here. A parallel of latitude. You could see it goes all the way to the latitude scale and ends at 41 degrees flat. Exactly. 41 degrees, 0 minutes in north. And it goes across the chart like this. It's also not that far from Montauk Point. So what that means is, if you were to get the northern distance, the distance of latitude between here and there, that is the difference of latitude above 41 degrees that Montauk Point is. So we can do that. Take your triangle again, line it up, this time with the parallel of latitude. Make sure you get the window directly on the line, and then line up this back line with the line as well. Have the edge land directly on Montauk Point light. Then take your dividers, place one at the light and one at the line. You're using the triangle here just to keep this going exactly straight. You're going straight up, because if you didn't have it, you could be like that and you wouldn't know if that's actually perfectly straight. So you take this, get your distance, and now this is how far the distance of difference of latitude from this parallel up to Montauk Point light. So if we now bring it over to our latitude scale, you could put the first one at the parallel we were working with, so 41 degrees exactly, and where the second one lands, oh, look at that, 41 degrees, 04.2 minutes north. You got the same answer that you did through the first method, but I would argue this was both faster and more accurate. So to review, you find the nearest parallel of latitude. We could have used this one up here. It doesn't make a difference. You could have used it and then measured it off of that, but we used this one. Line it up, get it in line with Montauk Point light, get your distance, and then bring that distance over to your scale. You can do the exact same thing with longitude. You can do both methods with longitude. So let's try and find the longitude of Montauk Point here now. Start with the first method, just to review it again. This time, instead of using a meridian, because we're measuring longitude, we have to set this perpendicular line with a parallel. So you line it up. This is nearly at the edge of how far it can reach, but you get this parallel to the parallel with the parallel. Then you get this, slide it over until the black line is striking the light right there. Hold that in place. Take your second triangle. Use it to slide the first triangle all the way up. And now where that black line intersects, you can see here's the 50. Here's 72 degrees over here, right there. So we're at 72 degrees 45 minutes, 72 degrees 50 minutes, 72 degrees 51, and then right there, there's a little bit of glare so you can't see, but that's 72 degrees 51.4 minutes west. Now let's try it with the divider method. And going back to it again, when you're using the dividers instead of just the triangles, instead of setting the triangle in the direction you're trying to go, you set it perpendicular. So now you line it up with a meridian, place it as close to Montauk Point as you can, measure that distance right there between the meridian and Montauk Point, and then now that is your difference of longitude between here and here. So you take that all the way up to your longitude scale, and you get the exact same number, 72 degrees, 51.4 minutes. So that is how you could take one location and find its value. What if we wanted to do the opposite though? What if we had a coordinate, a specific latitude and longitude, and we wanted to plot it down? We wanted to actually plot it on the chart. And this could be either if you're placing down a GPS fix or you're placing down a waypoint, whatever it may be. You want to put a position down on the chart somewhere. So you just would work the exact process we did in reverse. I'm going to pick somewhere around here. So that's, let's say we're trying to plot a position of 41 degrees, 03.2 north, and 072 degrees, 43.3 minutes west. So that's generally around here. I just made that number up. I might forget the exact number, so if it changes, don't blame me. Let's start with first the latitude. 41 degrees, 02.3 minutes. So we can come over to our latitude scale here. We've got 41 degrees. We want, I think I said 2.3. We want 2.3 minutes north of 41. If we wanted, you can always work in reverse too. So if your latitude was like 40 degrees, 55, or let's say 58, you would work from 41 down to 58 here. That works just as well. Actually, let's do that. We'll do the 58, not the 41.2. So 41 degrees, this is essentially 40 degrees, 60 minutes, 40 degrees, 59 minutes. So 40 degrees, 58 minutes. Let's do 8.3. So you get 40 degrees, 58.3 minutes north. And that is so now you have your distance away from this parallel, now going down instead of going up. You're going to bring that over here. This compass rose gets in the way and it intersects the meridian, so we can't use that. So we'll use this one over here. Measure it down this meridian because you have to go due south. You have to be going due north-south. Place a tiny little tick mark right there. So that is the accurate latitude of the point we're trying to find, and it's in the general area. Now what we could do, I said we're going to be going for 72 degrees, 43.3, I think I said, minutes west. So now that we have the latitude of our position, we can draw out a line off of that, an arbitrary distance. That looks like it's about right. Never mind that, there's a little bit of dirt underneath the chart that kind of threw off the line there slightly. That is something you want to watch out for. You want to make sure that doesn't happen. You have to be careful whenever you're plotting. But here's a line of latitude off of the exact latitude that we chose before, going due east off of it. And we know that our position will intersect that somewhere. So now if we come up here to our longitude scale, or we could have gone to the bottom of the chart, either works. We put our first point, let's see, we had 40 minutes here, 42, or 41, 42, 43, right there is 43.3. So we take that, and then we take where it hits 50, because 50 minutes west, 72 degrees, 50 minutes west, that was the meridian that we plotted that little line off of. So we take this distance, follow this meridian down, keep going, and then we get back to the line we drew. And we can see if we just found the difference in longitude between the point we're looking for and that meridian, if we place our first tip at the meridian and then our second one right there, that right there that intersection is our position. So that's the position we were talking about looking for the whole time. It is, I believe, 40 degrees, 58.3 minutes north, and 072 degrees, 43.3 minutes west. And then because you've made this nice big line, I don't have my big eraser with me. Where is it? Because we have this big line off to the side that we don't need, we can erase that now. Remember to always use your nice big eraser, not your pencil eraser. It's not as good. And erase it on that side as well. And now all you have is just that point right where you were looking for. Let's do one more. Let's work towards the bottom of the chart. So right here. That way everything's a little bit easier because you're right in the area you're working with. So let's say we're looking for 40 degrees, 44.5 minutes north, and 07. Ooh, okay, I messed up because I've been working with 071, not 072 degrees this whole time. 072 degrees, 08.0 minutes west. Everything I did before was accurate. I just messed up the degree value. So now we're looking for 40 degrees, 43.5 minutes north, 072 degrees, 08.0 minutes west. So first, let's do the latitude. That's what I always think is the easier one to start with. So we're looking for, we can start either from the bottom or the top. I think it's easier to start from the top because there's a lot of clutter going on at the bottom here. Start from the top at this parallel here. Measure down from 40 degrees 50 minutes down to 40 degrees, let's see, there's 41, 42, 43, so we're looking for 43.5. So that's just the exact middle point of that section there. So that distance I'm holding now is the difference between this parallel and 43.5 minutes. So let's move that over to this meridian here, just because it should be a little bit easier to work off of that one than it should be to work off of the latitude scale. You mark, that is the point we're working on. So that point right there, that is where we care about the latitude of that. So then you can draw a line off of it. And if you don't remember that your position is somewhere to the east of that line, you could draw it both ways. You could draw it out to the west as well. It doesn't matter. But you know that it's along this line somewhere. And you're going to now measure its longitude based off of the difference, the distance from its position to the meridian we're looking at here. And that meridian, by the way, is 072 degrees, 10 minutes west. So we're looking for 072 degrees, 8.0 minutes west. So if that's 10, that's 9, there's 8 right there. So we get 8, we bring it to 10, find that position precisely, then we bring that up to here, mark it right there, and then erase the excess. And you have the exact position you've been looking for this whole time. Again, if you wanted to use both triangles and just measure upward from here and then across from here, that would have been totally valid. And because we chose a spot that was so close to the corner of the chart, it wouldn't have been that much more difficult. I just think if we're talking about something way up here, it's a lot easier to measure off of meridians and parallels than it is to just come all the way up from the scale. That's my personal preference. It's not something you have to follow.